A certain gas takes 3 times as long to effuse out as helium. Its molecular mass will be how much? Means when you compare with the helium, the gas effused 3 times as the helium. Means let us assume the helium effused in the 10 seconds, the gas effused in 30 seconds. This rate of effusion is direct inversely proportional to their molecular weight, and also rate of effusion is inversely proportional to time. Okay, means the gas which effuse speed, it will take lesser time. Okay, the gas which has more weight, it will take more time to effuse. So rate of effusion is inversely proportional to molecular weight and inversely proportional to time. Okay, so from this we can make one formula like this: root over m2 by m1 is equal to T2 by T1, which is equal to R1 by R2. Okay, we can make formula like this. Okay, so use this formula and find out the answer. Let us assume here what is M2. What is M2? M2 here. What is the molecular weight of helium? Molecular weight of helium is how much? The given. Molecular weight of helium, let us assume that is M1. Molecular weight of helium is 4, right? And molecular weight of unknown gas, let us assume that is M2. We don't know, we need to find the molecular weight of unknown gas, M2. Okay, so time taken to effuse for the helium gas is how much? Let us assume that is T1. Let us assume that is T seconds. Time taken to effuse the other gas, T2, which is compared with the helium, it is 3 times more than the time as long as to effuse out as a helium. Okay, so the helium gas effused in T seconds, the unknown gas effused in 3 into T seconds as per the question. Just substitute all values in this formula, then you will get the answer, right? So root over m2 we don't know, so just you on squaring both sides. To remove this root, I am doing squaring. On squaring both sides, what will you get? This m2 by m1 equal to t2 by t1 whole square. Okay, so what is the value of m2? That is we need to find out. M2 we need to find out, and m1, the molecular weight of helium is how much here? 4. T2 value is 3 times of T, and T1 value is T whole square. T get cancelled, right? So this m2 by 4, 3 square is how much? 9. m2 equal to 9 into 4, so which is equal to 36 units. Okay, the molecular weight of unknown gas is how much here? 36 unit. Is it clear, everyone? 50 ml of each gas A and gas B takes 150 and 200 seconds respectively for effusing through a pinhole under the similar conditions. If molecular mass of gas B is 36 and molecular mass of gas A will be. Similar question it is, right? And let us say this is the T1 time and this is the time T2, and this is what gas B means M2, and we need to find the molecular mass of A, M1. Okay, we have a formula just now we have written, right? That is M2 by M1 M2 by M1 is equal to M2 by M1 equal to T2 by T1 whole square. Just now we discussed, right, in the last question. So what is the M2 value here? 36. M2 value is 36, and M1 value is, yes, what is the M1 value? That is we need to find. And T2 value is how much here? 200 seconds. And T1 value is 150 seconds. Whole square is there, right? So 0 0 get cancel, and 5 3 are 15 and 5 4 are 20. So 4 by 3 whole square. So this we can write as 4 by 3 whole square means 4 square is 16 and 3 square is 9. So do the cross multiplication. So then M1 equal to 36 into 9, so by 16, right? So use 4 table. 4 4 is 16, 4 9 is 36, 9 into 9 81. So 81 by 4 is we can write as 20.25. Okay, the molecular weight of A is how much here? 20.25 is not there answer. The answer is none. A bubble of air is under water at a temperature 15 degrees Celsius. So bubble of water. Now where it is, the bubble is here, under the water. Okay. So let us say this is the water, right? So here, what is the temperature here? That is 15 degrees Celsius temperature is there. Pressure is how much here? 1.5 pressure is there. Okay, now if the bubble rises to the surface, so when bubble is coming to here, right, its size somewhat increases. Why? Because pressure is decreases to 1. Pressure is decreases to 1 bar. And when it is come in a surface, what is the temperature here? Atmospheric that is the atmospheric temperature is 25 degrees Celsius and atmospheric pressure is 1. This is the pressure, 1 is the pressure and 25 degrees Celsius is the temperature. When this bubble is rises to the surface, the size of the bubble increases to how many times? That we need to find out here. Is it clear, everyone? When it is inside, under the water, the size of the bubble is smaller. When it is rises to the surface of the water, here pressure is decreases, volume increases. Pressure is inversely proportional to volume. Already you know that. Okay. So we need to take the relations between the volume, pressure and temperature. Listen here. Volume, pressure and temperature. Then already you know that according to Boyle's law, volume is inversely proportional to pressure. Volume is inversely proportional to pressure and volume is directly proportional to temperature. Okay. So when you combine these two, we get this formula. Volume is directly proportional to T by P. When you make a formula, then this we can write as V1 by V2 equal to T1 by T2, means it is directly proportional. 1 by 2, 1 by 2. And P is inversely proportional. So this we can write as P2 by P1. Okay, so now you find out what is the T1, what is the V1. So let us say V1. Initially the volume of the bubble is, let us assume that is V. So when it is this, when the bubble is rises to the surface, the volume of the bubbles becomes V2. That we need to find. V2 is how many times it is compared with the V1. And temperature is initially when it is under the water, what is the temperature? That is 15 degrees Celsius. To this you add 273, then T1 will become how much here? Yes, 288 Kelvin, right? So temperature, second temperature, when it is rises to the surface, the temperature becomes 25 degrees Celsius. This is the room temperature. So that is 25 plus 273. How much it is? 298 Kelvin, right? And the pressure inside the water, what is the pressure? Inside the water, under the water, the pressure is how much? 1.5 bar. Okay. And what is the, when it is rises to the surface, what is the pressure? Decreases to 1 bar. Okay, this is atmospheric pressure here. Just you substitute these values here, then you will get the answer, right? Now you see, V1 by V2 means V by V2. T1 value is 288 and T2 value is 298 and P2 value is 1 and this is 1.5. Okay, let us assume these are similar to each other. 288, 299, it is not a big difference. Let us assume 288, 288 will get cancelled. Assume as it is 1. Assume as it is 1. Okay. 1.5, 1 by 1.5, can I write 10 by 15? When you remove point here, we can put the 10 in numerator. Then we need to find the V2 value, yes or no? So this V2 equal to this 10 by 15, you take it this side, V2 you take it that side. Okay, this will become 15 by 10 into V. Okay, what is the value of 15 by 10? 15 by 10 value is 1.5 V. So it is nearly, it is matching with the answer A. So the volume will become greater by a factor of 1.6. This is your answer. Is it clear, everyone? Okay, we'll move on to the next question. A gaseous mixture was prepared by taking equal mole of carbon monoxide and nitrogen. If the total pressure of the mixture was found 1 atmosphere. The partial pressure of the nitrogen in the mixture. According to Dalton's law of partial pressure, the total pressure of the mixture is equal to partial pressure of carbon monoxide and partial pressure of the nitrogen. Okay, and the partial pressure of the carbon monoxide and partial pressure of the nitrogen both are equal. Why? Because they are in equal mole. The number of moles of carbon monoxide and number of moles of nitrogen also equal. The number we have taken equal in number. Then suppose equal number are there, number of moles of carbon monoxide, number of moles of nitrogen, both are equal in number and both are having same molecular weight. What is the molecular weight of the carbon monoxide? 12 plus 16, which is equal to 28 units. This is the weight of the carbon monoxide. And what is the molecular weight of the nitrogen? That is 14 into 2, 28 units. We are taking in equal in number and both are having equal weight, means, and both will create same pressure. Yes or no? We need to find the pressure of the nitrogen. This pressure of carbon monoxide, can I replace with pressure of the nitrogen? Why? Because both are creating same pressure, right? Pressure of nitrogen plus pressure of nitrogen. How much it is? 2 times of pressure of nitrogen. What is the total pressure of the system given here? 1 atmosphere. So into 2 you take it this side, it will become by 2. So 1 by 2 value is how much? 0. That is 0.